In this video, we cover the different types of steganography. So there are 4 general ways to hide information: using steganography with texts or documents, using steganography in images, using steganography in audio, and finally using steganography in video. So the first technique is using text. So there are various different ways to embed or hide information using text. So the first one is the word shift coding protocol. Basically, as you can see here, there is a little bit more space between the words in the first line and the second line. So by adding additional spacing, we're able to hide our information inside of this without anyone being able to notice the difference. The next technique is the line shift coding protocol. As you can see, between the first example, the word shift coding protocol, and this example, there's more spacing between the lines. So this is another example of how to hide our data inside of that extra spacing. The third technique is the feature coding protocol, which if you notice the difference between the first line and the second line here, the T in the has an extended T, and the F in fox has an extended F. So by changing the features, we're able to embed additional data inside of that. And the last technique is the white space manipulation. This technique involves adding additional white space at the end to hide our data in that extra spacing. The next steganographic technique is using images. So the first technique is masking and filtering. As you can see on the Mona Lisa here, we have a watermark, and this ensures that images are not being used without having paid what is necessary to be able to use that specific image. The next technique is the least significant bit insertion. Essentially, with the least significant bit insertion, you are taking a certain number of bits from one file and you're merging it with a certain number of bits from another file. So you notice that there is some distortion in quality when we use least significant bit insertion. The next technique is the direct cosine transformation. Unlike the least significant bit insertion, it doesn't distort the image, but the subject does have some noise. And then the final technique is the wavelet transformation, which we're basically going to store high frequency details separate from low frequency. So here's an example of masking and filtering used inside of printers. So if you use a microscope on a piece of paper, you may notice these yellow dots that you can barely see on this piece of paper. Now, what's interesting about this is a lot of printers will actually print these microdots. They're basically invisible to the human eye, but if you're able to use scanners to look at this, you can find out a lot of information. Take, for example, here's another piece of paper, and you can see those dots are kind of black. I'm going to highlight them here with yellow. And essentially, we have a row parity and a column parity to represent what data is stored on this particular piece of paper. So the column parity is 2 to the factor of n. So 2 to the factor of 0 is 1, and 2 to the factor of 2 is 2, and so on. And our column parity is just going to be numbered as we go left to right. So what we're going to do is we're going to take the row parity. So in this first column, we'll take 64 because it has a yellow dot, and we'll take 32 because it also has a yellow dot. And we'll add those two together, as well as 8 and 4. And that's going to give us 128. We don't know exactly what this represents, but let's go on. The next sequence is going to be our serial number of the printer. So you can see here that 21052857 is the serial number of this particular printer. And again, you're looking at the row parity for that specific column and adding all of those bits together to be able to figure out the number. So in this column 14, it's 16 plus 4 plus 1 gives us 21. Then we have a separator just to separate the serial number from the date. And here we have the date, which we're going to pull out 5621, which is 5 represents the year, so 2005, 6 is the month, so June, and 21 represents the day. And then we also have time. As you can see here, we have 1250 represented. So an interesting story about this is that the FBI was able to use this technique to arrest an NSA contractor because the contractor printed and scanned files and shared them when the files should not have been shared. But the FBI was able to look at these scans and determine using these microdots which printer it came from, who printed it, etc., and they were able to arrest the contractor. So let's give you an example of least significant bit insertion. So here I have a bunch of binary digits, zeros and ones, and let's say that we have the word bomb, and I want to insert that inside of my cover file. With least significant bit insertion, I'm just going to take each one of those numbers and embed it into each one of these bytes, a byte represented by 8 bits. So 0101111 is 1 byte. So I'm going to take the last bit of that first byte and put 0, which is the first bit of our B. And then I'll go ahead and do that across. So B is 0, 1, 1, 0, 0, 0, 1, 0. We'll do the same thing with the O and the M and the B. So what I want you to do is try an exercise on your own to create a Stego file by merging the embedded file below using 2-bit insertion. And in this case, we're going to just embed the embedded file completely over the cover file using 2 bits. So pause this video and try this on your own, and then come back to compare your answer. All right, welcome back. So to embed it using 2 bits, essentially I'm going to just keep the first 6 bits of the cover file and then embed the last 2 bits of the embedded file. So the first row would be 0, 1, 0, 1, 1, 0, and then 0, 0 coming from the embedded file. And then 0, 0, 1, 0, 1, 0, 1, 1. So it'd be exactly the same because the last 2 digits of the embedded file are 1, 1. And then it'd be 1, 0, 1, 0, 1, 0, and then 1, 1 coming from the embedded file. And so on until I've finished my least significant bit insertion. For audio techniques, we can also use low bit encoding, which is similar to least significant bit insertion, but this works with audio files. We can also use the spread spectrum. So there are spectrums that we as humans cannot hear, and data can actually be concealed inside of these spread spectrums that are outside of our normal hearing. Additionally, we can also embed things using echo hiding. So we hide data inside of the echoes. So now I want you to try a learning activity. So use steghide to extract the payload. So download the themes.zip file, open the terminal, and then navigate to the directory where you downloaded this file. Extract the zip file, and then use steghide and the password the last straw to determine which WAV file uses steganography. All right, welcome back. So I've gone ahead and downloaded the themes.zip file. And now we'll go ahead and open up the terminal. We're already in the downloads directory, so I'm going to go ahead and just extract that using unzip. I'll go ahead and hit enter, and you'll notice that 2 files come out, theme1 and theme2.wave. I can show you those files inside of the directory as well. So using steghide, we're going to extract it. And our stego file is now theme1.wave. I go ahead and hit enter and ask for the password, and here I'm going to type the last straw. And it successfully worked. It extracted the txt file. I could have tried this with theme2 as well and type in the password, and it will say it could not extract any data with that passphrase, meaning that theme1 had our text. So now I'm going to go ahead and just show the text of Beat Bowser. And it says, Bowser has terrified this kingdom long enough. The time has come for him to go. So the last technique of embedding steganography is inside a video. And this is going to use a combination of the steganography and images and audio that we previously discussed. Here I have a GIF. I know it's not really a video, but it basically shows you that we can embed information inside of a video. For example, you can see the little bird that is hidden inside of the eye of the bigger bird. Thanks for watching my video. Feel free to click the links here to watch the next video of the playlist, continue to the next playlist, or subscribe.